This is part 2 of the 9-3 instructional worksheet. Please stay engaged and get this whole thing done. So now we're going to be talking about 6 terms: conduction, thermal equilibrium, radiation, wind, convection, and thermodynamics. I'll be looking at each one of these, and go ahead, and if you're sitting doing this, you can respond, whatever. So let's look at letter A. Heat transfer through electromagnetic waves. Read these. I'm going to pause for a moment. You can yell out what you think is the correct answer. If you said radiation, you are correct. Our second definition says thermal heat transfer by the contact, touching of 2 objects. Yell out your answer. That's right. If you said letter B, you are correct. Conduction, you are correct. Third, this transfers heat by moving currents in gases and liquid. Again, take a moment. You only have 4 to look through this time. If you chose answer 5, convection, you are correct. There's only 3 left. What is the term that defines when 2 objects are at the same temperature? If your teacher wants to point at those to respond, that is perfectly fine, whatever you want to do. This will be thermal equilibrium. 2 left. Next, the study of how heat moves. This should be pretty easy for you. That is thermodynamics. And last but not least, we couldn't read this all, but just saying caused by convection currents, of course, that will be wind. Now let's move over to our second batch of matching. We've got the terms insulator, conductor, vacuum, solid, liquid, and gas. Let's take a look at our definitions. What is a region of space that contains no matter? If you chose vacuum, you are correct. B. What allows convection but is a very good insulator? A hint. This will be one of these 3 states of matter. And of course, the answer is B, gas. For part C, any material that allows heat to move through it easily allows heat to move through it. That will be a conductor. Now, next, allows convection and can be a good conductor of heat. This will be one of our 2 remaining phases. And of course, the answer is liquid. For D, what is any material that resists the movement of heat through it? We're down to 2 answers, and for this, the correct answer is insulator. Last but not least, no convection can occur, and no convection can occur in a solid. For this next block, we're going to write either 1 for conduction, 2 for convection, or 3 for radiation. So the correct answer will be either 1, 2, or 3. For our first scenario, when hot air rises, we are dealing with, the answer is 2, convection. When two objects are touching, give you a moment. And the answer is conduction. If nothing is touching, there's only one possible answer. The answer is 3. When atoms collide, and remember when they collide, they're in contact or touching. That will be number 1. Which one of these 3 transfers heat in all directions? Looking back, the only one that transfers heat in all directions is radiation. Next, causes wind. Wind is caused by currents, so that will be convection. What occurs between a stove and a pot? These are touching, so that will be conduction. Within a pan of water, and I'm going to make a pan of water on a stove. So it's a pan of water that's heating up. And that would make this one convection. Within the pan of water. Those are going to mean that it's sort of going like that, moving around. More of this occurs with dark objects. And that will be number, if you said 3, you are correct. And what can go through a car's window at night? This is sort of a weird one. I don't like this one. But we'll go ahead and do it anyway. So through a car's window at night. And this is probably going to be one conduction. Because at night we're not going to have light getting through. But we can have heat transferred through a window. Out of the following 4 scenarios, A, B, C, and D, 2 of these are at thermal equilibrium and 2 of them are not. Take a moment and see if you can figure out which are at thermal equilibrium and which are not. These 2 are not the same. These are not at thermal equilibrium. Here's 2 objects also not at the same temperature. These are not at thermal equilibrium. Objects B and C have 5 and 5, they have 25 and 25. Both of these 2 are at thermal equilibrium. Both of these 2 are. I'll highlight these 2. Next, we're going to be showing an arrow that shows the direction of thermal transfer. And remember, we always go from higher to lower temperature. So pointing an arrow down, we will be going this way. If you want to write it out here, you certainly can. Now let's do this one. Our direction of thermal transfer will be in this direction. Here's the third that we're going to do. And again, we will put an arrow from 25 to 15. Last but not least, here will be our direction of thermal transfer. Those are super easy. Next, we're going to write I for insulator and C for conductor. Remember, good conductors are anything that will conduct easily an electric or thermal heat type of energy. So our first item is metal, and this, of course, is a conductor. That was even given on the front page. So is this one. What is our insulator? So remember, a conductor, this will conduct energy, and this will not. Air. Think about whether this is an insulator or a conductor. The answer is insulator. Glass. Glass is not a great conductor. It's a better insulator, but it can conduct, so I'm going to give it an insulator. It can do a little insulating. This is questionable. You could probably go either way on that. Next, we have a penny. Well, a penny is made out of copper and zinc, which are both metals, so that would be a conductor. Is water an insulator or is water a conductor? Water can conduct an electric current, and it can conduct heat. It can be a conductor. I'm going to say it's a conductor, and that one I'm going to put a question mark by too. Just not because I questioned my answer, but I could probably let you argue either way on that one. On both of those, I put question marks. You could probably argue your way if you really wanted to take a stance. Next, in our third column, we have a coat, and a coat would generally be a good insulator. Styrofoam. We sometimes drink coffee out of styrofoam cups to prevent our hands from getting hot. That means it does not transfer heat well. It's an insulator. Last but not least, we have aluminum. As you well know, aluminum is a type of metal. That will be a conductor. Next, absorbs heat or reflects heat. So absorbs, A or R. Dark liquids. Dark liquids, everything that's dark will always absorb. Clear liquids. These would be interesting. They don't really reflect or absorb. You know, a clear liquid will absorb some heat, but they don't go super fast. I think I'm going to put an R on here. And that's also iffy. Shiny objects. These reflect heat. Dull objects, if you recall from the first page, absorb. White paper. Does white paper absorb or reflect? Most of you are going to get this one right. And black paper, your other one. Aluminum, and if it's shiny aluminum, it's going to reflect. Styrofoam and a dark car. Styrofoam is generally white, and it's going to probably reflect heat. And a dark car is likely going to absorb heat. Almost done. Does heat rise and does hot air rise? Let me go back up here and remind you of our very first thing. Heat transfers from hot to cold. Heat does not rise. Hot air rises. Does heat rise? No. Does hot air rise? Yes. So the particles with high kinetic energy hit each other harder when they run into each other and get further apart. They're further apart from one another. If they're further apart, that means they have lower density. And if they have a lower density, the result is they rise. Last but not least, let's take a look at this diagram. Is this diagram correct? Look at it. Is this diagram correct? No. Heat does not flow this way. Heat should flow this way. Heat flows from low to high. And now I'm done.